Hello, linear algebra. Today we are going to be talking about some material from section 1.5, solution sets of equations, specifically parametric vector form. So what I want to do before we get to parametric vector form is just remind ourselves what a few things in this section are. So first, this section deals with homogeneous systems, which basically is a linear system where the b's or the constants are all zero. So if you're in a linear system, it might look something like, 3x1 minus 2x2 plus x3 is equal to 0. The coefficients can still be whatever you want, but the right side is 0. So in a linear system, everything on the right side is 0. If you have it in a matrix equation, so here that coefficient matrix would be 3, -2, 1, -1, 4, -3, and the right side would be, that's not a matrix equation, this is the augmented matrix. So, augmented matrix. Whoops. All right, so there's the augmented matrix. The matrix equation is the matrix times the vector, and the vector is that vector of variables. Okay, because remember, each column here has to match up with one entry over here. It's equal to 0, 0. And in a vector equation, remember, you're going to have each column will sort of correspond to one variable. So you would have 3, -1, x1 plus x2 times the second column, -2, 4, plus x3 times that third column, 1, -3, is equal to 0, 0. All right, and we do, just by convention, put scalars on the left, which is why our scalars are on the left here. All right. And of course this is, oh, I could have erased it. I know how to do stuff in OneNote. Okay, so that is the matrix equation, AX equals B. All right, so let's look down at this theorem that we talked about in class the other day. So AX equals B has a non-trivial solution if and only if the following is true. All right, so let's remember the trivial solution is just the vector x equals 0, okay? Because if you have an equation like this one up here and you just plug in 0, 0, 0 for this vector, right, this is going to be a true equation. You'll multiply by 0 and get the 0 vector. So AX equals B always has the trivial solution. And remember that linear systems can have one solution, no solution, or infinitely many. All right, so basically homogeneous equations, we never end up with this because they always at least have the trivial solution. So the question is, are they here where it's only the trivial solution, so a unique solution, okay? Or are we here where there are other solutions, non-trivial, okay, which is just not the 0 vector. All right, yeah, where there's not a unique solution, infinitely many, non-trivial. Okay, so what's gonna go here is, whoops, this is supposed to be AX equals 0. Okay. What's going to go here is AX equals 0 has a non-trivial solution if and only if, when you row reduce, you end up with at least one free variable. Okay. If the equation has at least one free variable, and remember that is going to be a column without a pivot. All right, Now let's get to this piece. We want to go ahead and look at the following example. All right, we have a linear system, 3 equations and 3 variables. The zeros are on the right, which tells us that it is, okay, a homogeneous system. All right, so it has at least one solution. It's going to be consistent, okay? It has the trivial solution. All right, and we're wondering, does it have more? And we want to write that solution in what's called parametric vector form. So what we're going to do, we'll worry about this parametric vector form in just a minute. What we're going to do now is go ahead and put it into an augmented matrix and row reduce. Okay, and you might have already noticed row reducing a homogeneous system is really nice because one of your columns is just going to be 0 the whole time. All right, so we are row reducing here. We already have a 1 right here, and we're going to use that 1 to clear out this -4. Okay, so I am making sure my phone is on silent. That's smart to do while you're filming a video. Okay, so I'm going to do 4 times row 1. So 4 times 1 is 1, 4 times 3 is 12, 4 times 1 is 4, and 4 times 0 is 0. And then we're going to add that to the second row to get a new row 2. All right, so we got 1, 3, 1, 0. We add these together, we get 4, -4 is 0, 12, -9 is 3, 4, 2 is 2, 0, 0 is 0. And that other entry in that column is already zeroed out. All right. And we end up with something pretty convenient here. I made a mistake. What was my mistake, y'all? 4 and 2 is 6. Okay, so that should be a 6. All right, so now there's something super convenient. Here is our next pivot. It matches up nicely. So we're not even going to get it to a 1 yet. We're just going to go ahead and add those together to zero them out. All right, 1, 3, 1, 0, 0, 3, 6, 0. And now we're going to add these bottom 2 rows together. 0, 3 minus 3 is 0, 6 minus 6 is 0, 0 and 0, 0. So many zeros. All right. And right now, this is enough information to tell us, okay, here's a pivot, here's a pivot. There's no pivot in this column. This is going to be a free variable, which means that we have infinitely many solutions. And since we have all these zeros over here, we do have non-trivial solutions. All right. So if you are asked, does it have non-trivial solutions? This is as far as you need to go. You could stop here. We see there's a free variable. Yes, non-trivial solutions. But we want to know more information. All right. So we have zeroed out, right? Under this pivot is zeroed out. There's no other pivots here. So the last thing we need to do is zero out this 3. And I am just going to subtract those. Okay. So I'll do 1 minus 0 is 1. 3 minus 3 is 0. 1 minus 6 is -5. 0 minus 0 is 0. Okay. And let's go ahead in this same step. Since we see we can just divide this row by 3. Let's go ahead and do that. So 0 divided by 3 is 0, and then we would get 1, 2, 0. Okay, so what we've done thus far is write out our solutions like x1 equals this, x2 equals this. In this case, x3 is free. Remember, these columns correspond to x1, x2, x3. So x3 is free. It can be any real number. x2, I'm going to go ahead and solve for that, right? So here this is x2 plus 2x3 is 0. I'm going to take that that 2x3 and subtract it to the other side. Okay, and now here this top row would be x1 minus 5x3 is equal to 0. I'm just going to take that minus 5x3 and put it on the other side. All right, so parametric vector form. All right. Basically what we're doing was we're parameterizing our solution with the free variables. So I'm going to take this x1, x2, x3, write it as a vector. My vector x is x1, x2, x3. Okay, and I'm going to go back up here and replace my x1 with 5x3. x2 is minus 2x3, and then x3 is just itself. All right, so now what we have here is we have this single free variable. Every entry here is scaled by it, so we can kind of bring that out front as a scalar. Okay, and now we have, here is our solution in parametric vector form. So that is all we do. All right, I want to do one more example. We're not going to do the full row reduction, okay, but let's say, all right, let's say we row reduce and we get the following. So let's actually, we get 1, 0, 0, 0, 0, 0, 1, 3. Okay, and let's say, oh, actually, hang on. Sorry, that needs to be a 0. All right, and let's say 2, 5, 0, 0. And there's going to be a lot going on here just because. Let's do something other than 2. I'm going to show you what happens when there's a lot going on. All right. So here is this matrix, and it's in reduced echelon form. We have pivot, pivot, pivot. All right. And we have x1, x2, x3, x4, x5, and x6. So when we write out our solution, it is going to have 6 entries. All right. And we need to go through and do exactly what we did before. So for instance, this top row, the equation is x1 plus 2x2 plus 2x4 is equal to 0. I want to keep the pivot variable where it is and move the other ones to the other side. So that x1 is really equal to negative 2x2 minus 2x4. Then we come to x2. Well, x2 is free, so it just stays like it is. x3 now, Okay, we go by this row, x3 would be negative 5x4 from that positive 5 getting moved over, plus 7x5, not x5, sorry, x6. Okay, and then x1, 2, 3, x4, there's no pivot in the fourth column, it's free. There's no pivot in the sixth column, it's free as well. And x5, we take that positive 5x6 and move it over. So negative 5x6, x6 is free. So this is considerably more complicated than what we had in the previous example up here. All right, so what you do when there's more than one free variable is you split up into your free variable pieces. So for us, we have x2, x4, and x6. So I'm going to split this up into all of the x2 pieces. Negative 2x2, x2. In this third entry, there's no x2s for any of the rest of these. So for the last 4, there's no x2s. All right, and then we need the x4 piece. So negative 2 x4, no x4 in the second entry, negative 5 x4 here, just plain x4 here, no x4, no x4. And then we need the x6 part. There's no x6 up here, there's no x6 here. Here we have 7x6, no x6, negative 5x6, and x6. All right, so you just sort of split it up into the component pieces according to the free variables. And then with each of those free variables, we did what we did before and take it out as a scalar. So we're left with negative 2, 1, 0, 0, 0, 0. And here, negative 2, 0, negative 5, 1, 0, 0. Here, that x6 is taken out, and the coefficients that we're left with are 0, 0, 7 from right here, negative 5. Oops, I missed an entry. Okay, positive 7, 0, negative 5, and 1. Okay, and this would be your final parametric vector solution form. All right, so there are some examples of writing solutions in parametric vector form. Let me know if you have any questions about this particular video, and have a lovely day.